effective interest rate. And the problem says on June 30th, 2019, Gaston Corporation sold 810,000 of 9% face value bonds for $767,962.30. On December 31st, 2019, Gaston sold 350,000 of the same bond issue for $368.45.44. The bonds were dated January 1st, 2019, pay interest semi-annually on each December 31st and June 30th, and are due December 31st, 2026. Compute the effective yield rate on each issuance of Gaston's 9% bonds. Click here to access the tables to use with this problem. Round your answers to the nearest whole percentage. And so in the Google Sheet down here, it looks like somebody had already filled this problem in, but using the numbers on their problem, and those numbers don't align with this particular problem. So I just left that, and then I added a column over here for our problem. But so you can see that we're looking at the present value, and so that's the value of the bonds in this first case, the $767,962.30. The future value is what's listed next, and that's the face value, so the 810,000, and that's what when they're matured they'll be worth, or they'll have to be cashed in for. The payment is what's listed next, which is calculated as our face value of the bond times the percentage, which they gave us as 9%, times 1/2 because they're semi-annual. Then the number of periods, and we have 15 here because this was June 30th, 2019 through December 31st, 2026. And then to calculate the rate, we use the rate function. And so you'll type in rate, open parentheses, and then it's asking for the number of periods. And so we can just reference that cell because we typed all of this out into this list of cells. So in my case, it's G11, comma, then next, it's asking the payment per period, and that will be in the negative because it's a payment. So put minus, and then reference your payment cell, comma, present value, which is the $767,962 in our case, comma, the future value, which also needs to be entered with a negative sign. And then you can close the parentheses and press enter, and you get 5%. But that 5% is for the semi-annual rate. So we have to multiply that by 2 to get a 10% annual effective interest rate. And then we just did the exact same thing down at the bottom for the other instance where it was 350,000 issued at 368.45. And so just a few other things that I want to point out that could help you confirm your math in this problem. When we're looking at this first part, 810 value bonds for $767,962, because this issue price is less than the face value, we know that it was issued at a discount, which means the rate has to be greater than this 9% par. And so it is. And so that's kind of just like a nice double check. And then alternatively over here, 350 for 368. So the issue is greater, which means that the market rate is going to be less than our face value. And again, we can confirm that that is true. So I thought there was one other thing I wanted to highlight or point out about this. Oh, okay, sorry, I forgot. So the other thing is that you could solve for the present value and the present value annuity factors, and then in the tables find the percentage that aligns to the number of periods, and so that definitely can be done, but it's not obviously quite as accurate as using Excel to do it for you. And so for that reason, because typically that number isn't going to work out where it's exactly 5%. So for that reason, I really prefer using this rate function in Excel rather than solving for the annuity factor and then trying to find that annuity factor within the table based on the number of periods. All right. If you still have questions, please let me know. Thanks.